This is an iPhone 10 that came in with no power, and you'll see here that if we connect it to the ammeter, it will kind of jump around. It goes to 0.08 and then all the way up to 0.14 before going back to 0 again. So obviously something is interrupting the charging process here, and the phone is unable to boot. So we're going to pop it open and see what's going on. The first thing that I noticed on the inside is if you take a look at the battery connector here, it's got a bit of wear on it. There's also a capacitor missing right there on the right top side of it. So this phone's been worked on a little bit, and I'm not sure exactly what was going on at this point, but we're going to poke around and see if anything else looks out of place. Now if we take a quick look at ZXW, we can see where that capacitor goes, and it kind of makes me think that someone might have been on the right track, trying to figure out what's going on here. But if you take a look here, that's the BAT VCC line, and I found out later that that was not actually the problem. But if we take a look in some other areas here under the microscope, you will see momentarily that we are missing a complete shield. And yeah, I did notice that when I opened it up, but I wanted to save this for a surprise. So there's a couple of capacitors already missing from beneath an EMI shield that goes over the area at the lower end of the board here. So someone was attempting to repair this, is my guess. And you can see we've got these two VCC main caps that have been removed from the board. And I'm just going to assume that didn't solve their problem. So we'll just continue looking and see, just showing here on ZXW where those connect. So it looks like they were kind of thinking maybe one of these capacitors was the problem. They pulled them off the board, but obviously that didn't solve anything. I went ahead and inspected the rest of the board, and nothing really looks out of place here too much, so we're going to go ahead and pull it out of the frame. Now, despite a little wear there on the SIM card tray, most of this looks pretty clean, especially on the back. So my initial impression was that if someone split this board apart, they actually did a pretty decent job of getting it back together. It looks pretty much like factory. So at this point, I really didn't think that was the case, but we'll find out different momentarily. By the way, you're probably wondering, and yes, BAT VCC is actually clear. The diode measurement here looks normal, but if we move over to VCC main, as you might imagine, we actually do have a dead short to ground here. So again, I believe that whoever worked on this was on the right track, but they were not able to relieve that short. We're going to go ahead and install a jumper wire here on VCC main so that we can inject some current and hopefully get some direction as to where the heat is coming from. So with the lead attached here on the positive side, I'm going to use the other probe from my power supply, and we're just going to touch the ground. Pretty much anywhere that's ground here will do. And unfortunately, this did not produce any heat under the thermal camera. So at this point, we can be fairly confident that the short is internal. We'll go ahead and throw the motherboard here onto our heating platform, and I really like this one. It's almost exactly 3 minutes. You just kind of clamp this thing in here, set it to 185, and if you start a stopwatch, give it almost exactly, like I said, 3 minutes, and it will warm it up to a temperature where we can go ahead and lift the upper layer off of the lower one. There is quite a bit of nuance involved here, so I do recommend that people practice on this before you do it on a customer's phone. But you'll see my timer up there. Once it hits right at the 3 minute mark, the board starts to loosen, mainly on the right hand side first, so you'll be able to tell there initially. And you've just got to be able to perceive the difference between the surface tension of the solder and actually putting too much pressure, or pulling too hard and lifting any of those joints underneath. So again, it's difficult to explain, something that definitely requires a bit of practice. All right, so when we got inside here, the interesting thing was that there were additional capacitors missing on the inside of the motherboard, also on the VCC main line. So I again just kind of reinforces my idea that they knew that there was a short, but were unable to locate the source. And when I see that, it's kind of discouraging because it makes you think maybe it's underneath one of these ICs, hopefully not one that's difficult to remove. Now, since we know that the short is probably at the lower end of the board, what I'm going to do is pull the capacitor here at the opposite end. I like to inject current as far away from where we think the short is as possible, so that way there's no confusion, because the wire itself actually tends to heat up, as does the surface that it's attached to. So we'll just take this off and set it aside for the moment. And let's give this a test. Yep, that is clear. Just to make sure, there's always a potential for the capacitor that we removed to be the source of the problem, but that's pretty rare. And we can confirm here that we do still have a short on the board. And that is actually stuck pretty well in the flux, so I'm going to leave it right there for safekeeping, and we'll just smooth these out a little bit so we can add another jumper wire over here. Now, unfortunately, I haven't got the thermal camera here where you can see it, but that's okay, because what I want to do basically is just kind of isolate the heat to an area so that we can get a closer look under the microscope. And I'm going to use freeze spray anyways, but I could tell that there was heat coming from down here right in the area where those other two capacitors had been previously removed. So we'll get this thing nice and frozen and inject some current. I'm just attaching the ground wire, or excuse me, the ground probe over here. And you can see we have located the problem. The fun part, of course, is carving this component out, because we've got a whole bunch of sticky stuff in between there. So I'm going to speed the camera up during this process. I'm just going to use some heat, a very thin blade, and we're going to carefully get this thing kind of dug out so that we can heat it off the board. And I did manage to knock another capacitor out of place there, so we're going to go ahead and have to put both of those back on. Just a little too much sideways pressure. But we'll test this and confirm right now that this is in fact a shorted capacitor. And there he is. I assume you guys can hear that. This is the reason that the phone would not charge or power up. Now in this case, that small capacitor that came off is not a critical component, so I'm going to leave both of these off of the motherboard for the time being. I just want to get them pieced together so that we can confirm that we did in fact solve the problem. And for that, I'm going to use this iSocket platform. These are very handy. You can basically get the two boards back together without permanently installing them. This will allow you to do data recovery, test for some functionality. Obviously, there are some things that you won't be able to test, but once we get this all plugged in, we'll make sure that the phone powers up before we put everything back together. Now, once we get everything in place on here, we're going to plug in the screen, the charge port, and a battery. It's a little tricky sometimes to maneuver around here, so it'll take me a second to get this set up, but once it does, we'll have a power source basically coming from the battery, and of course when we plug in the charge port, that will prompt the device to boot, so we don't have to worry about trying to jump any pins together or anything like that. And with a little luck, hopefully this thing powers up, and we can then proceed with repairing the phone and getting it back to the customer. Alright, so we have everything pieced together. We'll go ahead and plug it in. And there is our Apple. Now I am going to cover this up just for privacy concerns, but fortunately it ended up that they had a very generic looking background, so I'll move this barrier here in just a second. And turns out they had a very generic looking background here, but there is a passcode, so we can't proceed much further. But so far so good. Looks like this one is going to be okay once we get everything put back together. If you found the video helpful, please hit the like button and subscribe to be notified of new repair videos in the future.